Hi guys, welcome to Design Technology TV. Today we're going to carry on our series looking at the OCR NEA. Today we're going to look at 1.3, 1.4 and 1.5, which are the investigations and information that you guys will need to look at the start of your project so that you make a decent start, but also as you move through the project, you should continue to do these investigations. Really importantly with the OCR NEA is that it is a linear project which should run in a chronological order. What that means is that you guys will do the investigations and find out more information as the need arises. In the past, previous specifications have looked at students have looked at research at the start of the project, which is fine, but the problem is that often they don't then fully utilize it or use it properly, or it creates this really onerous long-term piece of work that they do at the start of the project and then essentially forget. Fundamental to the OCR NEA is that as you highlight things that you don't know or find out information that you need to prove one way or the other, you should be using it there and then. This video will be slightly longer than some of the others because I'm covering 3 sections in one go, although there's lots of similarities. What I'll do in the description is I will timestamp 1.3, 1.4, 1.5 so that you're able to skip into those sections as you need so that you can come back to this video more easily later on. The strands link together. What you're going to first of all look at is creating focused and relevant information. Really importantly with this is that this isn't an opportunity or shouldn't be where you just go and find loads of information that's irrelevant just because you're trying to fill a hole. What you should be doing is you should be finding information about the things that are important to your project specifically, and so that it will actually reflect the needs of your project, your stakeholders, your user, so that you're actually answering the questions that arise rather than just finding stuff that you think, oh, that might be useful. I mean, on occasions there might be things which are just really a bit swervable and a bit unusual, but even then you should be able to show their relevance to your project in terms of what maybe specific part you're using them in or why that's inspiring you to go somewhere else and do something different. Each of the bits you go into here have to be detailed. Often what happens is students rely entirely on secondary information, i.e. information they've got probably from the internet. They and in those occasions they then don't go into looking at anything firsthand, i.e. looking at it themselves. That causes them issues in understanding the depth, because clearly if you're holding a product in your hand and you're able to look at it and possibly take it apart and disassemble it, you'll find that you understand the product in a lot more detail than you would if you just look at a picture of it on the internet. Maybe you can look around it on the internet, but that's all it is. So fundamental to this, and it's something all of you should do, is actually disassemble a similar product or a product or products which are related to different aspects and approaches you intend to take. From and throughout the moderation process, the moderators have found that projects that include disassembly and students that undertake that process as they need to are almost always far stronger, because the students doing it have a much better understanding of the details within the product and how it's manufactured and the component parts and the order they're put together, rather than just understanding what the external case looks like. Disassembly is key, so get on with that and make sure that you identify opportunities for it. You need to be critical and perceptive. Sorry, you need to look at down to the nut, the bolt, and the washer. This isn't just a GCSE kind of, oh, here it is, it does X. It should be you looking at it and understanding why it's made the way it is. You should also be considering DMFA, which we'll cover later on within the project work, but design for manufacture and assembly. If you don't know what that is, then look it up, because it's key to understanding how your product will be made in real life. Remember, this isn't just a case of you designing something as a lump and going, yeah, that'll be all right. You should be considering all sorts of additional aspects, and DFMA would be one of the stakeholder requirements that you need to cover. As I've already mentioned as well, these strands are ongoing. They're not I looked at it at the start of the project, I left it. What they are is you looking at it at the start of the project, potentially in some aspects, but then there might be bits you miss, bits you didn't even know you needed to look at, and as you go through the iterative process, you suddenly realize that you need a ball bearing assembly, or you need to have a component part that locks in a specific way which you've never looked at before. And then what you would do chronologically within your design work is suddenly go, right, actually I need to do this now, and it might be half a slide, a whole slide, it might be a short video where you actually then look at those component parts as the need arises. So on to 1.3. As with other other videos, we're going to focus on Markband 4 primarily. We talked about exceptional before, and we understand where Markband 2 sits in terms of the EU border. So Markband 4, we're looking at full and objective consideration of primary users. So the primary users are the people that are going to be using your project more often than not, and other stakeholders' needs. So stakeholders' needs are wide and varied, and you should have a conversation with your teacher about these if you're not totally sure, but you should be looking at what the manufacturer wants. You want to be looking at what the retailer wants. You want to be looking at is there governmental policy that's in place that dictates that your project has to do certain things. There's a really wide, varied range of stakeholders, and you should show that you understand their needs across the board. Students that comprehensively do that, i.e. they do the whole lot, often access the higher mark bands. When we then look at the next section, the next statement, a range of comprehensive requirements are identified. Those requirements will be linked into your feasibility study and also the brief that you've already done. But what you're doing in here, as you go through these 1.3, 1.4, 1.5, is actually starting to answer those questions. So something that I haven't really sort of made particularly clear until this stage, because now's the time to do it. In the feasibility analysis and in your design brief, you are writing 4 key requirements, as I've talked about before. However, what they quite often are, they are questions. They're not answers. What you're doing is you're saying, maybe I might do this. These are the things I'd like to do. When you get into 1.3, 1.4, 1.5, what you're doing, and the primary difference here with these requirements is that you're actually starting to show that you've got resolutions to, that you're finding out information that answers those questions. So an example might be that a shipping company is one of the stakeholders, one of your primary goals and your requirements is that you want it to be easy to ship. Okay, so that's a question, how is it going to be easy to ship? And then within these particular user stakeholder requirements and needs, what you're doing is you're then looking into how you might make it easy to ship in terms of that the packaging might form part of the product, or the packaging might be very minimal to reduce the amount of wasted space within your containers as they ship. You might understand better how that packaging might be made. You might understand how it might be important to protect the product within the packaging, etc., etc. So what you'll find as you go through 1.3, 1.4, 1.5 is this is the answers to what you're trying to do. Within 1.3, you will be having conversations with users and stakeholders. You may have already had a conversation with your user during the feasibility discussing where you're going with it. Here it might be you are finding out more information and more details of what it is that they want and also their perception of how things might work. You might take existing products to them and discuss with them why they don't work for them, where the gaps are, what could be improved. You'll also have stakeholders, so you'll be looking and speaking to stakeholders where possible. Quite often that's quite tricky to do for A-level conversations because, let's face it, how many people do you know that have a manufacturing plant that you can chat to? So often at this stage, one of the best approaches is to use other students as personas. So what you can do is you can get a group of students, each with a given role. So you might have one who is the person that's the retailer, you might have one that is the user, you might have another who's the manufacturer, etc., etc. And then each of those people play the persona, and what you do is you discuss your project and the direction you're going, and then they pose you questions about how that might be fulfilled. Where possible, visit places, interview people, particularly professionals, do observations, and again, we've talked about focus groups and surveys, how they can be a bit iffy in terms of their responses. However, they're still useful to do. Further consideration of the 5 W's and also how are you going to do it. We're looking at ergonomics and anthrometrics, and you'll see some examples of that as we move through. You need to show that you understand how big your product is going to be. You also need to understand how big your user wants it to be. If you speak to probably any of your teachers, I'm sure they've all got stories that are similar to me, where there's certain aspects where their students have gone off on a project and then come back with something that's just ridiculous in its size because the student never considered it, either way too small or far too big. It's a common mistake and one that you can easily make sure doesn't happen just by doing a bit of ergonomic and anthrometric detail at the start of the project or as it becomes needed. You'll also be looking at wider issues. So things like sustainability, how DFMA impacts what you're doing, etc., etc. We're also looking at then regulations, so you'll be looking at regulations, whether there's specific British standards or ISO standards that you need to stick to. If you're not sure what they are, have a look at those after this video. All of that stuff will come in photographs, audio, video, normal sort of stuff. Common mistakes. The user requirements are generic. So often what students will do is they'll find a picture of some ergonomics and go, there you go, ergonomics done. What they don't do is they don't look into it and look at the specific age group, the specific sizes of the people, or the gender, or the range of sizes they need to do. So what they do is they pick one measurement, and quite often that measurement tends to be themselves, which is fine, but then they don't look at outside that. So they design the whole project to fit them, which is okay sometimes, but then what happens is they then come to test at the end and they realize that they are either at the lower end of a percentile or the upper end of a percentile, or they haven't considered people at those areas, which means that at that stage then suddenly their mate who's just slightly bigger than them can't wear the product because it's just too small. You also need to consider the stakeholders' needs and make sure that they're considered in full. So often people don't pick out enough stakeholders, and then what they then do is they then don't look at what their needs need to be within that particular section, and also they don't understand what they want from the product in enough detail. So it's a bit of an overview rather than it going into that detailed level of information that we're looking at. Again, access and high marks, I'm not going to discuss through this. You can read it for yourself. Lots of information here about what makes it good and bad. Things that I will pick out as we go through is that it's done as you need it to rather than being front loaded. That you have direct contact with users and stakeholders and use personas where possible or where you have to. It's the ethos of the entire qualification is that you interact with people and that you use their feedback. So you should get started on that now. Also that it's got real-time investigations, as in you're doing it as you do it. Fundamentally, primary research is so much better than secondary. Look at legislation because you're A-level students. That means that you're going above and beyond what would be expected of a GCSE student. And then making sure that you are structuring it as you go through so that it's easy to follow. We can understand what it is that you're looking at and that you are able to communicate your understanding of the specific parts that are important. Here we see a leg brace project. This is one of several slides which aren't shown here. What the user is, or the student is doing is picking some leg braces. So he's found some examples of leg braces which you can see as secondary sources. He also looks at an actual leg brace, but not in this slide. He's then found relevant information from anthrometric book, which highlights bits, and then on the left-hand side, you'll note also in the center it says we've got some specific sizes. Each of those then are broken down, and what he will then do is he later on picks one of those size ranges to design for. You'll also notice that there's the sort of drawn image of the leg here, and what he's done is he's applied the data from these bits of information and measurements onto here. So he knew how big the product was he was doing, so he knew the size ranges would be between 13 and 18, 14 and 20, etc, etc. That means that he's got a very specific size that he's designing to. That makes the anthrometric data that's here relevant. If it's just the pictures that you see on the right hand side with no data drawn from it and it's just images, it's worth very low marks because you're not engaging with it, you're just simply displaying it. Same student then carries on, and how he's looking at the context, so the environment of use. Where is the product used? How is it used? What's great here is that he starts then bringing in his skills from other areas. So he also did maths, and what he's doing is he's bringing in calculations to show that he understands how many newtons are required for the lift, the leg brace to actually lift the leg mechanically by using averages of weights, etc., etc. He also looks at the staircases, and indeed there's several other slides within his project where he actually photographs himself walking up slides and does videos and analyzes how the foot falls onto those particular aspects. So what he's doing is he's using that data to guide how big the product needs to be, how strong it needs to be, what range of motion and movement it needs to do to be used in its standard environment of use. Here we've got a project where it's a fashion and textiles project. The stakeholders are identified, and this gives you it's a really nice overview of what the different parts of different stakeholders would want from the project. Great. However, it is a bit lacking in depth. We don't see any stakeholder interviews here, although there were some later on in the project. This is a little bit generic in its approach, and what we'd actually like to see is it broken down. So, for instance, we've got the fact on the right hand side that there's the government involved and there are regulations. What are those regulations? What specifically, how do they affect the type of product that's being designed here? Have more detail. We look at the advertisement on the left bottom hand side. So we've got advertising in TV adverts. Great. What does that actually tell us about the costs that are involved, the who that particular bits of advertising are going to go to, as in the user? How is it going to generate sales, etc., etc. So whilst this covers important aspects and they are useful, they certainly don't go into as much detail as you'd expect to see in a high order response. We also have this one, and within this one, there's some really good aspects and some underwhelming aspects. So if we've got anthrometrics on the bottom right-hand side, it's really basic. There's hardly any to it at all, and although we've got some other bits dotted around, it's not specific enough, and it doesn't really give us a full range of that data that we saw in the other one. We also have bits where we've got some sources of information coming across saying that these are, the averages, this is what happens, this is what needs to happen. What it's not doing here is you can't see where the information is coming from directly, which is always useful. And equally, we're not getting a full range of what this product needs to do. This project was designed about having access to a car and showing how the product, i.e. probably a wheelchair, would be able to access the car and get inside it. This limited amount of information, and this was the only slide, just simply doesn't cover the full range of needs for that access system. On the right hand side, we've then got the measurements, and there's 3 cars here that he's looking at using for the project. That's fine. However, why there's not first-hand information? If there was 3 that were secondary like this, that's fine. And if there was then another where he actually got access to a car, he took photographs, he showed the issues of access, the space that was involved, measured it, did a video, this would be a far stronger response. Because it's only secondary in its entirety, that does mean that the higher end marks are much more difficult to access. Okay, 1.4. So 1.4, what we're looking at is existing products. This is an area that can be done very well, but more often than not is done less well. Markband 4. Comprehensive and relevant information, sources of inspiration identified. It then influences the iterations that follows throughout the design process. So a couple of parts of that. First of all, throughout the design process, we'd expect to see this as you need it, as you go through the project. So it's not going to be entirely front-loaded. Having an overview before you start is always very useful. It needs to be comprehensive. That means that you've got to go into a significant amount of detail to get the higher marks. It's got to be better than good, which is Markband 3. To do so, the strongest thing you can do in this section is disassembly or reverse engineering. So finding a product or products which are similar or have useful components or aspects to them, disassembling them, taking photographs, really good quality photographs, but also doing a video and you discussing the component parts, showing your understanding and knowledge of why they've been produced the way they have, why they've been put into the design the way they have, maybe why other components have been omitted and not used. Because what you're showing there is you're showing your understanding of DFMA, you're showing your understanding of the internal components. If you think about designing a component part, let's say a leg on a table that folds. If you've only seen pictures of the leg on the table and you've only seen the hinge component or the pivot from the outside, you don't know the component parts that are inside it. That means that when you come to design, all you'll ever do is draw effectively a leg and then this magic piece of technology that sits within the leg and mysteriously makes it rotate. Most likely you'll resolve to things that you understand and you'll say, oh, there's a pin in there and it rolls. Great. However, if you've taken one apart or something similar, you'll understand how those pieces are fixed securely, probably using screws. You'll understand how the component parts are shaped and probably stamped. You'll understand the assembly inside it and understand that there's almost certainly some kind of bearing within it to make sure that the motion is smooth and repeatable. You'll understand if there's some section within it that's actually sat there to stop it, so it only moves within a certain range of rotation. As such, that level of understanding is massively different if you engage with it yourself, and it's one of the fundamentals to this particular section. Do it, otherwise you are just going to miss out on marks. Liking content. So tests and observations. You can test test products. You can trial them. You can show them in use. You can have a different range of different materials and show them against each other. This one works to do this. This one works there. This one doesn't work very well because it was cheap, and therefore this bit is likely to break, etc., etc. We've talked about disassembly or reverse engineering. You're also looking at projects or products which do things in a slightly different way. One of the problems students often fall into is that if they're designing something, then they look at something that already exists, and if they've got access to it, they look at something that is often very similar to the thing they expect to design. That means often they then don't have a lot of inspiration, they don't go anywhere exciting with it, they just end up designing something that's incredibly similar to the thing that already exists. That's not great with A-level because you're not showing your skills, you're not showing your iteration, and if your source of knowledge is only a single point of information, i.e. how something very similar is manufactured, you're probably going to use that for the basis of most of your designs. So quite often finding things that, as I already mentioned, are related, similar, but not the same can be very useful. You might also look, as I said, in this section at optimization, so reduction of materials, reduction of cost, etc., DFMA and all the things that are associated with that. You may also look at trend forecasts, i.e. why you might want to do things in a certain way, because there's fashions, there's new technologies, there's other things that are emerging that are useful from this section. Common mistakes. As I've already mentioned, using secondary sources of information so you only know an overview, not disassembling stuff. Understanding a breadth of products at a deeper level. So again, going from an internet perspective, routinely as a teacher and a moderator, I see my students, or not my students, but other students particularly, where what they do is they just use internet sources. It's a very generic view. They don't really understand the products. It's very low level in terms of the quality and detail and depth. And as I've always said, the existing products are very similar to the original. That causes issues. Accessing the higher marks. So what we're looking for here is you to look at the technical detail. What size washers have been used? What size nuts been used? Why have those things been chosen? Why were they strong enough? How do they fit within the construction of the product? Again, doing stuff in real time, i.e. doing it as you do it, recording it well, is key here. Having a hands-on approach, so that's that whole thing of not using secondary information all the time. Close-up investigation, showing us all those component parts, all the small details, looking them against what you expect to do in terms of your design criteria, looking them against other projects or products that are similar, can really help you to understand what's better or worse and why. Here we've got a design engineering project. What the candidate does is they start to play with basic programming language, so their understanding aspects. They also set up some simple loops using some breadboards, which we can see on the right hand side, where they start testing component parts and seeing what happens when they put certain inputs and outputs on. They also look at the main ways of potentially programming this automatic rover. On this one, what we've got is we've got a candidate who went on to design a really well-made project. However, she did it the hard way. She didn't look at any real first-hand material, did it all secondary. As you can see, these information or these shots are all off the internet. They're all photographs from elsewhere. And what she's done some very good quality analysis. She looks at it in some detail. She looks at a variety of different aspects. She understands why it's been made the way it is as much as she can. But the problem is, because it's secondary, it means that she's not able to look at the details of this. So, for instance, if we look at the section where we have our chair with these fold down sections, etc., etc., she looks at it, she can understand it to a degree, but she doesn't understand how the component parts fold up, doesn't understand how the component parts fold down, doesn't understand how the product is actually manufactured and made to make it the shape it is. that's an issue. Whereas if she'd looked at it in real life, she'd been able to identify those things. And what she ended up doing was going through a whole series of this, and only right towards the very end of the project, or what would have been the end of the project, did she suddenly realise that she didn't understand these things. And then she had to go back and then manipulate her own ideas and learn the hard way how to do it. It's much easier if you do it at the start of the project. This is then a bit of disassembly or reverse engineering. This student disassembled stuff and reverse engineered things throughout the whole project. The project itself is just really was excellent, and I will do a video on the whole project at the end of this series. The details here, there's two different products. One is a drag chain, which was part of a 3D printer, and then the other part was then a basin wrench used in plumbing. So there's two separate videos. She breaks them down into significant detail within the videos, where she talks about how they're manufactured, how they're made, what they do, how they function, and how these bits are then useful for her project. So the basin wrench particularly, talking about how aspects rotate, the range of movement, how they lock in place, what stops them from being adjusted further, how they are adjusted. That level of detail and understanding meant that her project that followed was excellent, and it meant that she was able to tap into these aspects as she went and understand why she was doing the things she was doing. 1.5. Here what we're looking at is materials, and this section is routinely done really badly. What students often do is they do a catch-all material sheet and then they go on and that's it. And you'll see how that has affected the marks. We have full and objective consideration of materials. So you're looking at a range of materials that are focused on your project itself. Also in Mark Band 4, we're looking at technical requirements. What do they actually need to do? Do they need to have a certain strength to weight ratio? Do they need to be able to support a certain amount of load? Do they need to be a certain weight? Do they need to have aesthetic requirements? What is it that your product, as it ends up, needs to have? The other bit that you'll notice is towards the end of the statement, when required throughout the design process. Routinely with materials, as a moderator, one of the things I can tell you is that when we look through projects, what we see is we often see students do a piece of research at the start which covers materials, and then when we get towards the end of the project, we never see those materials again. They're used at the start, they're named at the start. Maybe the candidate might latch on to one particular material or a couple, so ABS and aluminium, and then from that, the rest of the project is all just ABS, aluminium, ABS, aluminium. There's no changes, there's no deviation, there's no additional information. The research where they looked at the strengths, the weights, the technical requirements just simply aren't brought forwards, and it's weak. Likely content. So what we're looking at is relevant materials carried out as you go through the design process. Yes, you can front load it because you probably need to know some of the materials before you start, but fundamentally they should be as you go through the process as they come up. And if they change, if your requirements change, if your needs change, the materials should change too. We're also looking at what the physical performance for those things are. So often students just look at something in a very generic way. We're going to choose ABS because it's easy to injection mold and it's relatively scratch resistant and it's therefore usable. However, just stating that and then not looking possibly at wall thickness or how strong the material needs to be or the load it's going to be or the environment of use it's going to be used in, and then applying further requirements makes responses often a little bit weak. And the mistakes students make is they do this generic response that's non-specific, and I'll show you an example of that in a minute. They have limited choices where they don't use stuff, and they often, as I already said, don't use it later. They also don't interact with materials themselves, and it all comes from secondary sources where they get stuff off the internet and they just use other people's research without really understanding it. Accessing the higher marks. You can do your own trials, you can do your own tests, you can look at materials firsthand yourself, you can look at it as part of your disassembly and understand it. You can take stakeholder opinions about what they want from the product. You can think about where these materials come from and then bring in components which fit into wider issues, so sustainability and other issues. Though this is not marked in this particular section, there are sections later on within the design process where you're starting to look at the marks for wider implications. As I already said, looking at the physical properties, what they need to do, and considering what the requirements for the product needs to be. Here we go to the leg brace project again. This is actually a really nice bit of secondary research as much as it can be. Within it, what we've got is we've got a series of secondary sources that have been brought together. The candidate then shows with an existing leg brace what materials might be used where within it and shows their understanding of it. Rather than just naming these products, what they're actually doing is they're showing where and why they are used on this product. That makes it much more relevant and makes sure the things they're looking at are actually focused and higher marks than just stating the materials on their own. It's a really easy way of doing it, and having an image in the middle that shows us where you expect to use it on an existing product or similar product is really useful to see. What I wouldn't want to see here is a picture of your own final design later on, because it shouldn't be at this stage. You shouldn't have got to that. So think about the chronology of when you're using this. You may do a similar slide later on using your own stuff, but at the beginning of the project, we wouldn't expect that. We then have this, which is one of these generic, and they then don't use this. So first of all, within this, I never saw any information that related to this slide ever again within the folder. We also then have a series of bits of information where we've got generic materials. So we've got ABS, HDPE, PET, polypropylene, HIPS. Great. Just every plastic they could think of. And then we have a series of components on the other side which are just used as they're used. We often see as well at this stage material mapping charts, so charts that show what materials fall within either weight to strength ratio, etc., etc. However, they're not then used, or they're not really understood or unpicked in detail. Remember, this is A-level, not GCSE, so simply showing an image of some information isn't worth anywhere near as much as actually unpicking it and showing why it's relevant. Okay, well, thanks for listening. Next up will be initial ideas in 2.1, not 1.6. If you're looking at the mark scheme, you'll notice that next up is 1.6, which is the technical specification. Whilst 1.6 is marked within the first strand, strand 1, the material for it will not be created yet. What you'll be doing technical specification are things like technical drawings and how your product is accessible by third parties, so they understand what it is that you're actually going to manufacture. That does not happen now. There shouldn't be any work that follows 1.3, 1.4, 1.5, which is related to your technical specification immediately. That should come way further down the line once you've gone through the entire design process. So what we'll do next is we'll look at initial ideas. We'll talk about how to start moving through initial ideas, what's an appropriate initial idea in terms of its quality, and what that's going to contain. Thanks for watching DTTV. Like and subscribe.